Hi, welcome back to the stream. Today we will finish the mesh outline when you select an entity. Let's see if I can open the live stream chat. Never know. Hmm. The volume, I think it's not loud. It's quite the opposite. Maybe I should talk louder, or maybe add a. The volume is up to the maximum. How do you do it? Gain, a little bit of gain, a few decibels. The volume, I think it's not loud. It's quite the opposite. Maybe I should talk louder, or maybe add a. The volume is up to the maximum. How do you do it? Gain, a little bit of gain, a few decibels. I hope you can hear me better now. I hope at least. Okay. So, I fixed the issue that I had yesterday where I couldn't render the same mesh. Obviously, it was all of my fault because I was using the wrong handle, the wrong mesh handle. So now I completed the first depth pre-pass for this deselected mesh. Now I'm trying to figure out why, like, this shit is happening. I don't know why. Like, I'm trying to inflate the mesh, the yellow mesh, and only render where the depth is less than the actual mesh depth. I don't know what's happening, because for this mesh, for example, it's all yellow. Oh no, there's some weird artifacts. I think I should investigate. Let's go in debug. Let's run render doc and see what's happening. Alright, we have our depth pre-pass, which renders correctly the mesh, and then we have the yellow inflated mesh that it's rendered on top, and it should not be rendered on top. You see, the mesh is actually bigger. It's inflated too much, actually, but we have the depth compare less. Maybe that's the issue. Because let's take another snapshot of a tree. It's all weird. What's that? We have two separate draw codes for the one for the trunk of the tree and one for the leaves, because we have two different materials. Wireframe mesh. It's actually, yes, inflated. The triangles are apart from each other, so it's not what I expected. But okay, that's why we have all these weird triangles. We should fix the correct. We have the depth compare greater. Depth test. So we have 0.98, which is far away from the camera, because the max depth is 1. The closer to the camera, the closer we get to 0. So obviously expanding inflating the mesh will have a smaller depth values. So that's why I put the compare depth to greater, because I expect only the pixels that are farther away behind the first tree pre-pass to only be drawn. I don't know why this is happening. I have no idea. I'm actually transparent. Nice. Why am I transparent? Like, there's something going on. There's something going on with the green screen. Filters. Let's remove a filter. Okay, you can see the green screen behind. One of them is fucking up my transparency. Well, what happened there? This one, the last one. Okay, who cares? Nope. Okay, who cares? Let's move on. Okay. So, why? Okay, we have depth 98. 98, 821, 98, 82. Which is it's not greater. This is obviously bigger. 98, 8, 2, 3, 2, 1. Why it passes, I don't know. Compare greater. Depth right disabled, depth test enabled. What the hell? It's weird. Because I'm actually reading, since I'm not writing in depth buffer, I'm still reading the tree behind. So if this is green, it means that it has greater depth value than the tree. Okay, so this must be some kind of backface, because because I have no face calling at the moment. See, should be that triangle behind. Should be some triangle behind. We could enable face calling. I'm still not understanding why greater. Because this is not greater. If infinity is 1, you can't go beyond 1. So maybe my assumption is that using only the depth buffer, it's not so easy to do. It would be easier to use a standstill buffer. Still can't figure out why the inflate amount, it's so little. Because the model matrix should make it even smaller. Why is it inflating so much? It's still inflating a lot. I don't know why. See how big it is? I don't get why it's so big. If I remove these, I put it plate position. I'm not even inflating. So what's happening? Is it loading the cache shader? No, it's impossible. I'm not using the cache yet. The main inflate. Let's not use the inflate function. Let's use the original position. Where is it? Here. Let's not use this inflate position. And let's see what happens. Okay, I can't see from it. I need to run it from render doc. I can't tell if there is a difference. Okay. Now it's not inflated. Because it is moving the position by the normal value, which is not scaled. I've removed it for debug purpose, but I actually broke it by doing this. So if I run it again, it should inflate the right amount. Okay, I don't think it inflated anything at all. Maybe the value is too small. Let's increase it a bit. Let's see again. Okay, I think now inflate it a bit. I can already see it. Okay, now we have the depth buffer that is failing on the like it's inverted, so come on. So if we have like less than 1 depth, then what do we do? If we inflate the mesh, it will have a smaller depth value because it will also get closer to the camera. So maybe I should be doing it only for the back faces, maybe. I'm just guessing at this point. Let's cool the front face and see what happens. We render underneath the back faces, which obviously will have lower depth values. It's not working. It's not working. It's not working. Could you please tell me why? Okay. Topology. Scissors, depth test. Think the face culling is not a dynamic state of the pipeline state object. Set line width, topology, depth, stencil. I don't wanna use a post-processing effect. I could make it, but should I? Is it faster? How does it work then? No, we have a okay, the calling is per pipeline state object. It is fixed. So let's see once again what faces did pass the depth test. Let's see for the tree. Kinda looks better. Kinda. Oh. Let's see. It has less faces. Could be easier to debug. So we are rendering only the back faces. Stencil, graphics pipeline, create graphics pipeline. Oh my god. Dynamic state, line width, scissors, stencil, nope. Rasterization, front face, counterclockwise. So the mesh has all the faces. The vertex out has all the faces too. So what am I seeing? Let's see the wireframe mesh. This should be a front triangle. Why is it rendering? It should not be rendered at all. Okay. Outline, post processing shader, screen space shader, comparing depth. If there is a difference, exceeds a threshold. Yep. Like we could make a simplified version, not an edge detection, only outline shader. I think we have to change this strategy. So we must render only the in the depth buffer. So we have a clean depth. What? Why is it rendering the depth faces? I checked the wrong pipeline configuration. None. Okay. Yeah, because the fact that inflating will create these gaps between triangles, it shouldn't be a big of a deal if we only get the outline, but it won't look smooth at the end. So I think the post-processing approach could be easier, more lightweight and faster to make. But since I don't have a post-processing pipeline yet, we're gonna treat it as a normal render pass. Let's see what it does. No, it doesn't work. It's not working either. So let's scrap all that we have done. Okay, we only need a shader now. Inflate. We could define another shader. Let's call it a post-process quad, and let Copilot write the function. No. Should have nothing. No input. No. Come on. No input. Now we have const float 3. Position. Post-process triangle. So we actually don't need 4 vertices. We can just render a triangle bigger than the how do I say? Okay. I saw it in a Resident Evil engine paper or whatever. Triangle shader post processing. Let's see if I can find it. find the pretty frames. Deferred pass, shadow pass. Nope. Okay, this is the surface. It's just a massive triangle, bigger than the full screen viewport size. And I'm not a big fan of the two quads method, so good thing that made me love Reach to the Moon engine more. So what we need to create a triangle bigger than the viewport, is double the viewport size. And this is triangle position. Okay, so we start the... Oh, nice. Okay. How we define the triangle is... make it like this, no? Okay. Oops. Something like this. Okay, it's not perfect, but you get the idea. Okay, so the on the left. Oh, so in Vulkan NDC coordinates. In Vulkan we have the center, like OpenGL. Yep, those are NDC normalized device coordinates. So, if I'm correctly, we should have a triangle that starts. Let's get paint so we don't get this wrong. We should make a triangle that goes from here, double the size. Same thing here, double its size. Like this. Okay, so the first point is -1, 1. Okay, let's set it. Bottom left, which is -1. Why is 1? If y is up, what is wrong with it? Is it correct? I'm doubting myself right now. -1, -1. What is this? GLM. Come on. Okay, -1 to 1. Yes. So the center is 0, 0, 0. Top left is -1 because points down. Yes. So means positive y values move the vertex lower to the screen. So it is 1. Then we have the top right. There is no top right, you moron. Top left. The top left is gonna be -1. Yes, because this is wrong. Does not exist. The y goes down. Come on. The y goes down. So this is -1, -1. Then the bottom right is gonna be 1, 1. Yes, correct. We don't actually need a float 3. We only need float 2. Just remove these bits. Okay. Okay. We have the triangle positioned. Now we could just output the position color. Color. Just a white color. Texture coordinates. Texture coordinates must be the same, because this is gonna be minus bottom left. It's -1. But the top left, it's not -1, it's -2. And same thing bottom right is 2 on the X, because it's gonna be double the length. Okay. For the UV coordinates, it's the same thing. I just can't remember the slang shader vertex index. How do you get the vertex index? Ah, okay. You receive it into the main function. Vertex index here. Position the same thing. Fragment position. It's the position. Yes. Okay. Post-process triangle. So we have our vertex shader that we can call without any vertex buffer bound. We can just like just execute the draw call without any vertex buffers, because it will use these values as vertices. So now one thing. Okay, let's get it inside the engine first. So when we load the vertex shader, we need to compile this function, our entry point. Okay. Then we need a another pixel shader. Let's call it post process outline. Yes, outline editor. Let's leave a comment. Post-process outline share used to create outline objects in editor. The problem is we've got a texture and we got a sampler. Okay. Only output the color when. Okay, no. The input texture must be the depth buffer texture with only the depth information of the object. Okay, that is almost correct. We got a final color, RGB, So, const float, max depth, difference. Okay, what is doing? It's helping me. Thanks, Copilot. So we got the input fragment position depth minus the input position depth. Okay. So if depth difference red outline is bigger than max, we just discard the fragment. Otherwise, we return its color. Okay, so post-process triangle. We don't need it, but I would still leave it here. So what we can do, as Copilot suggested, is that we can use the if we use like a default render pass, we have the color scene buffer, and then we use the depth buffer of the pre-pass of the selected mesh. So we output the color on the final scene color buffer, but we are actually comparing the depth difference inside the fragment shader. So this way I avoid making a separate post-process pipeline. It could in theory work. I'm not sure. Let's give it a try. Maybe it's actually the easiest approach for the outline shader, since we already have a custom depth buffer. So now we must not use the unlit shader. Where was it? You have to modify the second pass, the selected object. So we have depth test mode. Should we care about depth testing? This way we're gonna always we have a depth difference, which could also be a depth difference from inside, not only from the white, which is the one value. So we could also have some outline which I don't know. It could still look cool, I don't know. Kind of silhouette shader. I wanna see it in action before judging it. So, the outline path material, depth test, um, greater. No, wait. Since we are rendering what? Wait a moment. I don't want to render the mesh. Okay, okay. We still need the post process pass. Okay, forget everything. So we don't actually need this anymore. I'm gonna delete it later. So we have this editor gizmo pass overlay. This is a world render forward pass. It is this class right here. What I need though is a different class. Post, let's call it post processing pass pipe. The same constructor as before. Begin, draw, and okay, does nothing. Okay, because here inside it does things. It renders the draw items and such things. What I actually need is a freaking material. How I'm gonna do it? Because we don't have access to the material. The descriptor set up there. So frame graph resource provider. Jeez. All of a sudden, it's not so easy. So, because we need to pass the depth buffer from here. Where is it? Here, after we render the selected mesh inside our custom depth buffer, we would need a memory barrier. We need to transition the depth buffer image from the attachments like depth write and stencil write to the shader resource, shader attachment resource state. We can do that, but to be able to bind the descriptor set, which the descriptor set is fixed, is this one. It's all based on the material descriptor set layout. So in some way I would need to mimic the same behavior of the material, but it's actually not a material. And at this class, there is no way to do this. This, huh? We have a material resource. Because the render, no, the world renderer has a material sync queue, which automatically updates the descriptor sets on demand. In GPU material manager. Okay, get creator get. So because actually to make a post-processing effect, we would need a custom pipeline state object. Yes, we should. Because we could fake it by sending the normal world forward drawing pass a fake draw item with an empty camera projection without no mesh information, and using the GPU material, but this GPU material, okay, pipeline format, what's that? Okay. There's actually, you don't really care about this in the post-processing, depth testing, all those things. So you just need a pipeline state object, a descriptor set manager. Where is it? Where is it? Okay, we have persistent descriptor set manager. Don't really care about persistent. I think I also wrote a render interface. I wrote some kind of like use and trash one-time use descriptor sets. I don't know where it is right now. Shader manager. No. It's not right here. Material manager. Persistent. I had it somewhere. Okay. Transient descriptor manager, which you can allocate a descriptor set that gets used and then released after the frame the GPU has done rendering using it. So we could use this class if it works. We need a shader description layout with the bindings. Okay, what do we need? Okay. What we actually need now, we need to define a new shader type. So it's not world now, it's gonna be post or pp post process vertex core slang. So gonna copy this inside here. We don't need anything. No push contents for now. Only one output. Maybe. What do we need? The normals? We don't need the normals. We don't need the color because we don't have any color. We've got the position, the UV coordinates and the frag position. Yes. Okay. Post-process triangle. And now for the post-process pixel core slang, we copy this thing here, ps input, a bit the same. PS input, okay. And now what we actually need: texture and sampler. Yes, we need these bindings. We have to read from something. And then we need the post-process effect. Just gonna copy and paste it here. I'm gonna create a default post-process that does nothing. Post-process default, which just returns nothing, I guess. Thank you. There is no input color, by the way. Material UVO, no. To linear, to sRGB. Base color, I don't need the base color. What? I have it here. So the text color, I think I will move this to the world pixel core. Static gamma, yep, nice. So I'm gonna just copy this. Okay. Default. It's gonna get the texture color, whatever. Stop helping me, Copilot. Because I don't have the utilities. Who cares? It's already in sRGB, so just return the color. Return, I don't care. return the texture as you received it in input. Now here we've got a texture, a color. We don't have any color. Outline editor. No, just return. Let's do this. Outline color is just a red. And we return the outline color. Nothing more. Okay. We have a lot of things to fix now. So these are the same. Frag position. Okay. Texture coordinates 1 and 2, yeah. I don't really care. 1 and 2. Alright. Now, from the engine standpoint, we must load the shader first. Where do we load it? So, load the post-process shader. Shaders include, okay. Shaders include okay. What does it do? So it looks for vertex and pixel. Okay. We must create. These one are the core files. I'm gonna create a new folder. Post processing. Here. Gonna create a vertex, which is we'll just have and include the post process vertex core. Okay. The same thing for the pixel. Include post process pixel core. Nothing more. So from this shader, include post processing. It will load by default the pixel and the vertex, which will have these entry points defined by default. Post process. Let's call it now the pixel shader main, and the same thing here, because it's actually a main, since it's required here to have at least these two, so we follow the same principle. So now that we have the configuration path to load the shader, and we have to specify include path shader path back. Now let's get to 1 entry point for the vertex, the fragment shader, because we have the default one, which is the main. Then we also want to load this one, the post-process outline editor. So the default one are added by default. This is an extra one we add manually. And now include path. Yeah, we must add this include path so it can find these two files. Now I think we can just load get shader program. Okay, we could just load graphics shader from this config. Of course, I have to change the name. Default post-process shader for the handle, and then default post-process shader program. Okay, so if we now run, it should compile the shaders fine. Let's see. Should compile the shaders fine. Okay, get lot from handle, get shader program from who, default static mesh unlit shader. No, because we don't have these. Let's see. Entry point not found. Post process outline editor, because it doesn't exist. So it didn't create the shader. That's why it failed. Yeah, I forgot to remove it. Okay. The shader vertex input does it has a different vertex attribute input, which has none. How do we specify the vertex shader input? Here, vertex contract. I should define another vertex contract. Static mesh. Contract type. Let's add post process vertex contract. So by default, it will try to return vertex contract from folder. Yes. The vertex contract, get vertex layout binding by vertex contract. So let's define an empty vertex layout binding. Post processing, which is empty. So I forgot the colon. Like this, return nothing. So now it won't trigger anymore that check, because it expects to have these attributes inside the shader using the shader reflection, but they are actually not defined. There is nothing in input from the vertex data. So come on, compile faster. Can't be empty. Who is creating a pipeline state object? Who? What? Default pipeline. La 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 la. Create vertex layout. Vertex layout. Vertex contract. Shader program. That's not real. Config shader program. It has a vertex contract of post processing. It can't be. By default. That's so wrong. Because when we load the shader, we should set the correct vertex contract. So before returning, maybe here, I don't know, shader program, come on, shader ID, then we have the vertex contract, vertex contract, contract type. Yes, I forgot this assignment. And I hope that's it. There is nothing more to fix. Alright. There's something going on with the validation layers. Draw parameters required. Wow. I don't understand. If P-code is a pointer to a SPIR-B code and P-code declares any of the capability listed in the SPIR-B environment appendix, one of the corresponding requirements must be satisfied. What are these requirements? Let me see. I don't understand. What's this? Let's ask ChatGPT. What this means? Uses a draw parameters capability, but your device does not have required feature or extension enabled. It means the shader uses built-in base vertex. This requires support for shader draw parameters. Compiling with newer semantic GL base vertex. Yes, maybe slang for this vertex ID. ask ChatGPT. No, it's not the cause. Only maps GL vertex index. Yeah, because it worked previously. That's not required draw parameter. What's wrong with my shader then? Your shader is fine, nothing should trigger draw parameter. The save does not require shader draw parameters. The error is not called by the shader. But your shader does not use any of them. It's outside this function. You're compiling with a pipeline configuration that enables draw indexing. Yes. Maybe. What's in here? Let me see. Post-processing. No, there's nothing. There's nothing I can debug. What did I do wrong? I don't understand. So, maybe what are the flags that I'm using for shader compilation? Okay, create Vulkan session. Spear V 1.5. Options. I'm not using much. I'm using this. Let's copy and paste to ChatGPT. Slang is quietly being helpful. Vulkan being strict. What version of... I'm using Vulkan 1.4. So, what's the problem? Slang is enabling draw parameters implicitly. There's a big clue. Slang may assume modern Vulkan feature set and enable option capabilities speculatively. Slang may over-declare. And I know I can't. Enable Vulkan features. I'm not setting any version. I'm not defining any strict version of the shader. Maybe that's the problem. It wasn't an issue before this. Okay, let's go inside the Vulkan context and let's enable the feature. Where are the features? Validation layer, extension, device extension, what? Initialized device. Oh. There is no shader draw parameters. What? VK physical device. VK physical device features too. Huh. Oh, what the hell? Let's try to not compile this new shader. I'm not really sure if the post-processing shader is messing around or I did something wrong in the world shader. At first glance it seems everything's fine. Maybe this static variable, maybe. Um, let's put it again inside the where it was before. Maybe that was the problem. No. What requirement? What are you talking about? Come on. Okay, what did I do? The static unlit. Okay. Discard. These are new. Here I removed these. Yeah, I think I should it like inflate position. Okay, who cares? Don't really need these at this point. Neither these. This is all I need, a post-process shader. Let's recompile. Oh, there's something going on. Float 3 by 3, post-process triangle, inverse. Come on, yeah. Just need to copy and paste. I will clean up later this inverse. What? Is it used here? Inflate. Do we need to inflate? Okay. What? Compile shader. I need to remove the entry point. Process triangle. Yes. Oh my god. I'm so dumb. Alright, the validation layers are not complaining anymore. So let's recompile the post-process shader and see if it compiles fine. Okay, something shader draw parameters is required. Okay, one feature. Okay, let's enable this extension. Should be an extension since it's validation layer now. Instance extension. Device extension. Yes. Huh. No. This one. Okay. I was missing this extension. Alright. Now I need to specify the okay, you see? It's not screaming at me anymore. Now we need to pass this shader. Not shader. We must create a pipeline from it. So let's copy and paste the pipeline config from somewhere. Okay. Create PSO. And forward pass we get a color and depth. Yes. Depth test. We don't really care since it's a post process. So compare always. Depth right false. We are not gonna write. Actually, we don't really need. Okay, let's get this. Get post process attachments. We only have the color. We have no depth. We have no depth. We have only color. Default blend mode, yes. Cool. No culling, it's just one triangle. And now we create the shader. So default post process PSO data, and we pass the shader program, shader stages. we must define the shader entry points. So, okay, we don't need them anymore, so we could create them on the stack. Shader entry points. Alright. We need a vector. Or an array, depends. It needs a vector, okay, who cares. Gonna create a temporary vector. Post. Okay, thank you Copilot. We have the main for the vertex. Then we have the post-process outline editor for the fragment shader. And we're gonna just pass this forward path shader layout. What is this? The shader layout. What is a shader layout? Huh. The descriptor set IDs. What? No. I can't believe what I'm seeing. Shader layout. Alright. I need to create a descriptor set layout in Vulkan, which is just an object that represents what the shader will accept in input, which is our thing here, the texture sampler, and that's it basically. So shader layout. Okay, now forward path, we need to create another one. Post process shader layout, and we're gonna go and define it here. Equals descriptor set IDs. It's gonna have only one descriptor set, which is only for these two bindings. The vertex will have nothing, will not even have a push constant for now. So what? Save D5 is newer. Okay. So post-process shader layout ID shader layout. Now it's gonna be a post-process descriptor set layout ID. Yes, this way it's clear. So renderer context, yeah, create descriptor set, create shader descriptor set layout. We need to define the shader bindings, no, the shader descriptor set layout, which will have its bindings. The layout will have bindings at 0. It will have a, come on, name, storage type, a binding type, texture. What's wrong? Ah, it has a constructor, okay. String name, okay. Texture. Binding type texture. Then we have the size, I don't care, it's not used. One element. And the stage is gonna be fragment. And this is the binding index. So at 0 is gonna be texture, and at 1 is gonna be a sampler. Sampler 1 shader stage. So I'm gonna create this descriptor set layout. Then the post-process descriptor IDs will have only this binding, which I'm gonna actually fix the set set 1 set 0. Okay, set 0 0 and 1. Index 0, and this is the set index, and this is the first one is the binding index. So we have, this is our first set, which is set 0. Binding 0, we have the texture. Binding 1, we have the sampler. We create the descriptor set layout. The shader layout has only this descriptor. And then we will use this to create a pipeline state object. It's just 10, 20 lines of code, but it's very tedious to do right now. At least it works. It could have been better, but who cares? Let's see if it can't create. So, because the PSO manager will always try to create a vertex layout. Since my abstraction layer has this assert inside, which can't be empty, doesn't make any sense. Who cares if it's empty or not? You see? Nothing explodes. It's missing a piece of the mesh down there, but who cares? Let's see the... Oops. What is happening? Let's remove this. Who cares if it's empty or not? It's not actually a requirement. It doesn't make any sense if you want to try to render something, but in post-processing it makes sense. Okay, the validation layer, I'm not screaming. Okay, I guess it's working as intended. Now we must create a custom pipeline. We have this new forward a post-process pass. Here it is. We need to define the draw function, what it does. Context. It also needs it depends on the context renderer. Yeah, to remove the dependency. Yeah, I know. It's gonna need the a pointer to the transient descriptor manager. Yep. Transient descriptor manager. The render pipeline. Who is gonna create the render pipeline? Nobody. Okay. We need this transient descriptor manager. It has the context, so we could move this code inside there, or we can create externally and just pass the pipeline state object ID inside. I don't know which approach is better. For now, I'm gonna only pass the pipeline state object ID. I'm gonna post-process. I don't even know. So, the transient description manager, it will need a shader descriptor set layout. Okay. Create descriptor set pool, descriptor set layout ID. It will create the ID for me. So this one here can become a transient descriptor manager post process descriptor manager. It's gonna be a unique pointer for now. Okay, so I'm gonna instantiate it here. Transient descriptor manager, I need the context and the shader descriptor set layout, which is this one. There we go. And now it's gonna call this function from inside, and I can just get this. I can get the ID, descriptor set layout ID. This one can no longer exist, because I don't really care. Could be inside here. Yes, why not? Okay, like this. It's gonna get destroyed because it's allocated on the stack. Give me a second. Okay. So, uh, we have our PSO. We have our pipeline here. We need to give it to the this post-processing pass pipe somehow, somewhere. Um, I think yes, I should create, not create. I should duplicate the transient descriptor manager. So, and so I have it here. Okay. Okay. I guess in 10 minutes I'll end the stream, or even less than 10 minutes. So, we have a reference here. We should inject it from here. Transient descriptor manager. Come on, Copilot. You're not helping me at all. So, we need also the pipeline. PSO ID. I think we could create it here. We already have the post-processing descriptor manager. We're gonna give it to the world render pipeline. If we have more than one, I don't know. Okay, let's leave it here. No. This can go inside here. No. Inside the world render pipeline can go here. So if we pass the descriptor manager, Okay, we are gonna move this unique pointer. We're gonna initialize it here after the resource provider. Resource provider, yes, right here. Move this one. Thanks, Copilot. Okay, so we can create the post-process pipeline ID. But we don't have the pipeline manager here inside. No, let's not do it inside here. Okay, but I don't really care about this. PSO ID. Ah no, we need the whole structure that it returns. Gather, create, cached. Return a reference const. So this must be const pointer. Okay, so Jesus. Now the world renderer, where it is created. I don't. World editor view. World renderer. It's created down here. So PSO data. Okay, like this. We're gonna pass it to the. No, it's gonna create the world renderer, not the world pipeline. It's the world view that has its world render pipeline. So we need to pass it there. It's kind of tedious to do. Anyway, since the world view has the world render pipeline inside, it creates the render pipeline. Here it needs a descriptor, post-process descriptor manager. Okay. Yes, give it to me. Like this. Okay. Must apply it also to the header definition. We don't need this namespace. Okay. Now when we create a world view, we move this post-process descriptor manager. Okay, it has its manager, whatever. This binding can go inside the post-process pass structure. Who cares? add a to-do, move to the then we must also pass the pipeline ID, post process PSO ID. Yeah, ideally you would create it inside somewhere, not in the editor, because every post process pass might use a different shader entry point. I don't know. Ideally that would be the best choice, but until then I could just create it externally and inject it. So the render pipeline post process and you have C post process select mesh outline pass outline post process pass. So we must pass a reference and the PSO ID here. Okay, like this. Now, when we draw, we must define the attachments. Gitmo dev buffer for now. Then I use the editor post-process pass draw, which is gonna do. Okay, it's not defined. We're gonna define it right now. Where did it go? Don't save. Come on. Under this one. It's gonna be pretty much the same for the render pass, bind render targets, clear, I don't care. It's gonna have a depth, so it's a clear pass. It's never a clear pass for now. Then we need to bind these things, the pipeline, PSO ID, the width, height, scissor, depth test, false. What? Oh yeah, it depends on the material, but we don't have any material, so everything is to false. Always. Topology triangle list, stencil test, false, scissor. We already set up the scissor, so set up twice. Now we need to bind descriptor set, some descriptor set. Okay, we're gonna create the descriptor set later. Draw, indexed, no. Context, just draw. 3 vertices. First vertex 0, 0, 3 count, instance count, only one instance, first instance ID 0. Okay, it's gonna draw our shader triangle, this one, using the vertex index. Now for the descriptor set, just gonna need to update the descriptor set. So descriptor transient, come on, transient descriptor manager, allocate descriptor set. Okay, it's gonna create a new descriptor set. We have our descriptor set. Now descriptor data, we need to update the descriptor set. How are we gonna do it? Okay, we can update it after we have bound it. What does it do? So I use allocate. Okay, get a free descriptor set. It returns a descriptor set from the free descriptor set. Okay, if it's not empty. Otherwise, to allocate a new one. It's gonna put them here in the deferred queue. It's gonna push them inside the free descriptor set. But it's never added to the deferred free descriptor set. So this class, I wrote it but never tested. It was never tested, so I guess I have to fix this class. Then basically we must update the descriptor set with the attachments we need. In our case it would be a depth buffer. So we need to transition after this draw render pass from write to read, then back to write. Oh my god. Yeah. I guess this is all for today. I hope to make another live stream soon. I'll keep you updated on my progress. See you another time. Bye.